Performance evaluation of inspection technology. The Japan Bridge Engineering Center, JBEC, is an organization that supports tasks for the promotion of introducing new technologies for bridge inspections in the road sector under the supervision of the Ministry of Land, Infrastructure, Transport and Tourism, MLIT. Based on the plan to promote the introduction of new technologies, JBEC supports in editing inspection technology catalogs under the advice of a technical committee consisting of experts. Inspection technology catalogs are composed of a set of performance values for standard items specified by the government, whose values are compilation of the list submitted by developers in catalog format. Two types of tests are conducted to verify performance of each technology: standard tests and field tests. Standard tests are used for verification of technologies that have different measuring principles but the same measuring items. The tests are composed of some reproducible tests to be done under the common and restricted conditions to organize the results so that the performance of various technologies can be fairly compared. Field tests are conducted using a test piece or an actual structure in the field, so as to assure operationability of the technology. The video consists of two stages. The first half of the video shows some examples of standard tests. The latter half shows the operation checks conducted on actual structures in field tests. If you are interested in to know more details about these technologies, please contact our local staff. Please enjoy the video. This is an evaluation test of stability. This test is done in a wind tunnel facility to evaluate the performance of wind stability of UAVs. This is an evaluation test of measuring accuracy for concrete delamination. This test is to evaluate the accuracy for detection of delamination in a test piece incorporating fake delamination inside the piece. This test to evaluate the range of motion. This test is to evaluate the flight condition by UAV along with the test bridge. This test is to evaluate the measuring accuracy for crack width. This test is to evaluate the measuring accuracy for crack widths made in specimens incorporating fake cracks with various widths. This test is to evaluate the measuring accuracy for the bearing dysfunction or displacement. This test is to evaluate the displacement of a bearing by a passing vehicle using a sensor installed at the bearing. This test is to evaluate the accessibility. This test is to evaluate the accessibility of the device into the space between the main girders of the test bridge. This test is to evaluate measuring accuracy for scour and topography. This test is to evaluate the measuring accuracy for the underwater specimen in a water tank under the changing turbidity and flow velocity. This test is to evaluate measuring accuracy for the bearing or anchor bolts dysfunction. This test is to evaluate the ability to detect defected anchors in a specimen embedded with both consistent and defected anchors. This test is to evaluate the measuring accuracy for deflection or strain. This test is to evaluate the measuring accuracy for deflection and strain by the passing vehicle using sensors and strain gauges set at arbitrary positions on the test bridge. This test is to evaluate the positional accuracy of orthoimage. This test is to evaluate the accuracy for both the distance between two markers and the coordinate values calculated from the orthoimage by comparing measured results with the coordinate known 3 markers set on the test wall.
Examples of inspection technology used on real bridges. Field tests are conducted using a test piece or an actual structure in the field, so as to assure operationability of the technology. Bridge inspection by using UAV. This test is to confirm the operationability of the inspection work under the deck slab using UAV. This test is to confirm the operationability of the inspection work at the high piers. This test is to confirm the operationability of the inspection work inside the box girder of the bridge. Bridge inspection by using movable bar type inspection device. This test is to confirm the operationability in inspection work under the deck slab by using movable bar type inspection device. Bridge inspection using the endoscope camera. This test is to check the operationability of the endoscope camera used in the inspection work in narrow areas at the end of the bridge girder. Bridge inspection by using USV. Surface drone. This test is to check the operationability of the USV in the bridge inspection work under the very short span bridge. Bridge inspection by using UUV. Underwater drone. This test is to check the operationability of the UUV in the bridge inspection work for scouring around the bridge piers. Inspection work for tendons of cable-stayed bridges. This test is to confirm the operation ability of the inspection device for tendons of cable-stayed bridges. Bridge inspection using onboard radar unit. This test is to check the operation ability of the onboard radar unit in the inspection work on the upper surface of the bridge deck.